Alright, finding maximum and minimum point for a function. If we're given a function here at any point, we know that for any maximum or minimum point, which is the turning point as well, because it's from increase to decrease. Alright, and so the tangent should be like this. It's a horizontal line, which means that the slope equals to 0. With this piece of information and our knowledge of differentiation, which is differentiate finding the slope expression for all function, we will be able to find out the exact point location of x and y of the maximum or minimum point. So let's take an example here. For example, we will have y equals to x minus 2 and y negative x. Alright, so we first need to differentiate it first. So we have dy dx. Using the product rule here, because two things multiply. So in the front bit, we have 1 y negative x plus the back bit. So negative 1 y negative x. Alright, rearrange it a little bit. And then taking a common factor. Then this is the slope equation. We want the slope equals to 0, so we have to put that into when dy dx equals to 0, which is the slope equals to 0. So we will have 0 equals to e negative x and 3 minus x. Using our now rule, either e negative x equals to 0 or 3 minus x equals to 0. This should be rejected because ex have to be bigger than 0. So we have x equals to 3. Now we got our point here, our turning point x coordinate there. So we put the x back to the original equation. When x equals to 3, y will be equals to 3 minus 2 times e negative 3. So we have e negative 3 as the y coordinate. And therefore, the turning point is 3 e negative 3. However, we only know that this is a turning point. We do not know whether it's a max or min. To identify the max or min, we got two methods. Number one is a sign diagram. I hope you still remember the sign diagram. Otherwise, you might have to look into the previous video. So by sign diagram, we will have a point here, which is 3. It is the point when the slope is equals to 0. And then we need to check out for other numbers. So anything smaller than 3 would be a positive, and anything bigger than 3 will be a negative. You just have to substitute any number in that. Therefore, it goes like this. Going up, 0, and then negative again. So or by the second derivative, so we could have the 2y dx squared, which is differentiating our previous expression. So we perform our product rule again. Negative e and negative x. Copy whatever in the front. plus taking the negative out, three plus 1 is 4, and then we put x equals to 3, so the 2y dx squared at 3 would be equals to, and that is a negative number, therefore it's a maximum. In general, we will, to find the point, we have for f(x), we differentiate that and put it equals to 0. Find the value of x and then use that to put it back to the function to find y. To test the point, you will have to perform the second derivative and then substitute this number in. If it's negative number, it's a maximum point. If it's a positive number, it's a minimum point. You can also use sine rule to test it. Oh no, not sine rule, the sine diagram. And this is the maximum and minimum point for differentiation.